moving on to optimization. So we're asked to find the dimensions of the rectangular box. So we're working with this guy first. We're told it has a square base. That's going to be important. And we're finding the greatest volume. Okay. So step one is usually to draw a picture. You might be asked to draw a picture on the exam. The picture is just to make your life a little bit easier to visualize what's going on. We're already given the picture, so we don't have to worry about that. Once you have something to work with, you want to get your first equation on the board, which is going to be your constraint, because we need two equations. We need constraint and the equation to optimize. So the constraint is always going to be given to you. You just have to write an equation. So anytime you see something like may not measure more than or has to be less than, that's always a constraint. It's something that we have to be within to find the greatest of something, right? So this is our constraint statement. So we need to convert this into an equation that we can do something with. So 108 is length plus girth. I hate that word. I'm not going to say it again. But that G word, look at this. It describes this side plus this side plus this side, right? So that's, I would say, the perimeter. Okay, we can write a perimeter equation. If we just call this x and we call this side y, then this guy's also y and this guy's also x. So this is going to be 2x plus 2y. Okay, so for our constraint, we have L plus 2x plus 2y is going to be 108. But let's see what we highlighted in purple. Square base means x equals y, right? The perimeter of a square is always going to be 4x or 4y. However you want to do it, it does not matter which one you do, because for our solution, we'll have L equals something, and we're going to have x equals y equals something. So it doesn't matter which one you choose to work with. I'm going to go with x because I like x better. So our constraint becomes L plus 4x is equal to 108. So this is our first equation. Your constraint will always equal the number for the most part. Like all the problems I've seen in this class, we're always setting our constraint equal to a number because we're constrained by it, right? Okay. Once we have our constraint on the board, we want to figure out the equation to optimize because we want to find a maximum. So the largest of something means we want to find the derivative of volume and set it equal to 0. But first we need to figure out what our volume equation is. So volume of a rectangle, hopefully we know this, is length times width times height. But let's be careful about this because really the length here is our height. So really the volume of the rectangle in this scenario is going to be L times X times Y. But we already know that X plus Y are equal, or X and Y are equal, so why don't we write that in so that our volume equation is just Lx squared. All right, so those are our two equations that we are going to use. The reason we need the constraint is because the constraint always gets plugged in here. This is the hard part, is making the constraint and making your equation to optimize. The derivative should not be the hardest part, okay? Because right now, if I were to take the derivative of volume, I would need to do product rule. I'd probably have to implicitly differentiate in one way or another. I don't want to do that. So let's make a substitution. So we have L plus 4x is 108. And then we have our volume is Lx squared. So what we're going to do for our constraint is we're going to solve for a variable. I say let's solve for L because we have this x squared here. So let's avoid FOILing. So that means we get L is 104 minus 4x. Now, this L is the same as this L. So we're going to rewrite volume with this new L plugged in. So volume is equal to 108 minus 4x times x squared. Okay? So our next step is going to be set v prime equal to 0. So we need to find the derivative of v, but I don't want to do product rule, and I don't want you guys to do product rule. So this is what we should do instead. Let's multiply this guy in, because if we do that, we get 108x squared minus 4x cubed. Now we can just do power rule. Seriously, you should only ever need to do power rule. Like, if you can derive here, I wouldn't derive here, okay? Just make sure you actually take the derivative, because so far all we've done is just some algebra. Okay, so now I'm ready to find my derivative. So I want dv dx, because that's my variable x. Okay, so using power rule, I get 216x minus 12x squared. Okay, I found my derivative. Now I'm going to set her equal to 0. What do these have in common? Well, they have an x in common. And 12 actually does divide 216. So if I pull a 12x out, what am I left with? I have 18 minus x. Now this is a lot easier to see what my x values are equal to. So traditionally I would have x equals 0 and x equals 18, but because we're doing an optimization problem, this doesn't make sense, right? I don't want the length of my package to be 0 or the width of it to be 0. So we're not going to look at that. We're just going to consider x equals 18. Okay? So first we want to verify that this is, that this would be a maximum for our volume. So how we do that is we see what happens to the volume if my x value was slightly smaller, and what happens if it's slightly bigger. Okay? So I'm going to plug these into my derivative, and then it'll tell me what's happening to volume as we go down or we go up, right? So if I plug 17 into this equation, I'm going to have positive times a positive. So that means my derivative is positive, and that means I'm increasing on v. Okay, if I plug 19 into this equation, I'm going to have positive and then a negative. So that means my derivative is negative, and that means my volume is decreasing. So what this means is for dimension x, if it's less than 18, I'm going to start increasing. My volume is going to be increasing. But once my x value gets bigger than 18, my volume starts to decrease. So this is how I know that 18 will give me a max. Okay, remember the original question said find the dimensions. So the dimensions are going to be L, X, and W, right? We said earlier our solution, I erased it, that our solution should be L equals something, X equals Y equals something, right? Well, we just found X, and we know X equals Y. So X equals 18, Y equals 18. All right, we need L. Well, good news is I have an equation to give me L if I have X. So L is going to be 108 minus 4 times 18. which I believe is equal to 36. So my solution looks like this. Make sure you answer the full question and you find everything that it's asking you for. If you just stopped at